Okay, so question 4 is given some data. It's non-linear data. If you were to grab that ruler of yours and try to draw a line, you can see it doesn't quite work. So they also supply that data for you as actual, let's get rid of that red line for you, as actual numbers, which means you can stick them into your calculator later. Okay, this is quite a simple question, but apparently 56% of people got it wrong. Weird. All right, let's just check this. We've got to do some rounding and 3 significant figures. So let's have a look at what all that means. So if we've got 0.00855385, then this number has 1, 2, 3, 4, 5 significant figures. Any zeros here are just placeholders. And if we had zeros over here, they would just be placeholders as well. So these are not significant figures. So not sig figs. And also at this end, not sig figs. Sig figs, significant figures. And you see that later on, I'll show you when we're doing the calculator thing, that it'll just say on the calculator, something like when you press this numbers in, you'll actually get 8.5385. And it has this e-neg3 thing here. This is actually how the calculator expresses scientific notation. What they're actually trying to say is 8.5385 times 10 to the neg 3. So this is what we mean by scientific notation. And the reason for scientific notation is it makes it clear these significant figures. How many significant figures? Well, there's 5 digits, there's 5 significant figures. So it's quite straightforward then how to do this. And this part here is just the moving the placeholder part. Okay, so again, we're rounding to 3 significant figures. So 1, 2, 3, chop off. We only just look over at the next one. This one is not important. It's not altering anything. It's not 85. We're just looking at the 8. The 8 makes the 3 go up. So our number is 0.000854. Could be quite embarrassing if you're getting that one wrong. Now, as I said, let's just try and do some of the calculator work on this. So if you take your data and put it into the calculator, just always getting another habit is to check that this actually is, list 1 is your X and that is your Y. They had the graph before, so you should better get all that right. And they said they wanted to do a log transform. So what you got to do is you click down here and it will say cal equals. So don't put another equal symbol here. I keep putting equal symbols in there because I'm thinking it's Excel. And you just go type in log of list 2 because we want to log this one. And then it will shoot out all these values here. And so now we can do X first, and this is going to log. This is log of Y. Remember, if you have log, it means log 10. It's the same thing. There's no difference between log and log 10. It's just a shorthand to say log rather than log 10. And you put all that data in, and then you can do all your calc linear regression. But remember, this time your X is list 1, but we want to do it against the transform. So you've really got to make sure that you're doing list 3 in there. And so if you do list 3, you'll get these values spitting out. And there's that number from before, the 8.5385e neg 3, which tells us we've got the 5 significant figures times 10 to the neg 3. And there's our other value, there's our A, which is we're going to use in the next question. So just get the hang of putting all those things into your calculator and practicing that. So in the next one, based on what we had in our calculator, we can just type those values in. Now, this is not really that hard a question because they already gave you one of the values, did they not? So they've made it quite easy for you. So you just got to make sure you're getting the right significant figures on these things. So you've got to round all of your answers to 3 significant figures. So we already did that partly. So the first part was our gradient, and so we know this one's got to be 0.00854 because that's the previous question. So first of all, make sure you're putting that bit in the right box. And the other number we got, because my calculator was set to Y equals a plus b dot x. Your calculator may be set differently, so please make sure you're getting into a habit of which one you're doing. So the b is next to the x, so this little symbol here, remember, that's times. So there's our times up there, so we know that the b is next to the year, which is the x. So our a value from the calculator, I don't have to show you that to you again, but the a was given as minus 14.396. So let's count our significant figures. 1, 2, 3, 4, 5. So that's 5, but we got to round it to 3. So we've got to cut off at 3. And so we just look over the fence at this one. Don't need to see anything else. And the 9 means that goes up one value. So it's not minus 14.3, it's minus 14.4. So minus 14.4. And there we go, all done. All right, generally people tend to freak out a bit with logs, and so they don't go very well, but they've told us that log 10, I mean, we know it's 10, of area equals 2.85. So you got to do is undo the log, and you just do that by saying then, well, the area equals 10 to the power 2.85. Now again, calculator speak. If you just press on your code 10 hat 2.85, you get a number that is 707.9457844, and you've lost your mark because it says round your answer to the nearest hectare. So that means to the nearest whole number. Again, it's amazing how people lose marks for rounding. So that's the nearest hectare. We look over the fence at this number. None of that matters. The 9 makes it go up. So your answer is 708 hectares. Okay, all good. Now, you have to then do part 2. Give a reason why this prediction may have limited reliability. There are 2 things that affect reliability. So 1, extrapolating. 2, the other thing that screws up predictability is low R. So you have that, which means like, you have a weak correlation. Again, I'm just giving you extra information so that when you think about these questions, you might think, what is the broader family of questions this comes from, and what other answers you might need to give to slightly different questions about the same topic for next time. And next time being the 2018 exam. This is the 2017 exam. So obviously we are not talking about R or anything at all, but this is definitely extrapolating because it said 2020. And if you remember from that data table, our latest data point was 1980. So you can just say extrapolating beyond the data range. I think that's all they wanted you to say. So extrapolating, definitely extrapolate both directions beyond the data range. Okay, so you can't extrapolate. You can extrapolate a little bit, but we've gone from 1980 was the last spot, and then we're predicting for 2020. So you can see that obviously we've gone quite a bit of distance.